on this page, you can see that your calculator should be active. So that means you can definitely use your calculator on all of these problems for these graph key features. You will find all of your function key features on pages 1 through 3 of your Unit 4 notes. The big things that I want you to take away from this page are increasing and decreasing intervals. You state as X value intervals. Minimums and maximums, you state as Y values. And when it says type, it means relative or absolute. But remember on my math lab, when it asks for a local maximum or minimum, that means either. For the symmetry, even, actually, yeah, we'll write here. Even means it is symmetric across what? The y-axis. Has to be across the y-axis, so it's not just that we can fold it in half like a butterfly. That butterfly's body has to be right on the y-axis. So that is even symmetry. Odd symmetry is rotational symmetry about the origin, which is 0, 0. So a cubic function would have rotational symmetry. An absolute value function would have even symmetry. But if either of them have been shifted left or right, then it's neither. Questions on that? When in doubt, you can always compare your key features exactly on your calculator. Where do I go to find a maximum and minimum exactly? Second trace. There's your minimum button, there's your maximum button. You go left of the point, enter, right of the point, enter, and then your calculator claps on the value. So use that to figure out maximums and minimums, and sometimes figuring out those will help you figure out if there is exact symmetry. On number 9, what do I need before I just go right to my calculator and start plugging it in? Parentheses around the top and around the bottom. So make sure when you're typing those rational functions in, you use your parentheses. So that's it for page 4 on that page. Flip back to the previous page. And we're ready to do our last little blurb on restrictions. So first, the places where you will want to study these things are page 5 of the notes and that yellow sheet if you still have it. If not, it's posted on Canvas, but the notes should be good enough to get you there. That's where you can distinguish between vertical asymptotes versus holes. Page 3 is where you will find your info about horizontal asymptotes and how to use trace or table ask to find them. Trace or table ask. So folks, we're going to start with problem A. Does this have any restrictions? Yes, we're dividing, so let's go ahead and take a closer look at our denominator. So x squared plus 6. Excuse me, I can't factor it. So we're just going to set it equal to 0 and say we don't want that. So x squared can't be equal to negative 6, square root. And x can't be equal to plus or minus I rad 6. folks, is that a restriction that I care about? No, because when we are talking about domain restrictions, we mean actual X values that we can possibly get. So this, because of the imaginary unit, means there are actually no domain restrictions. Which means our domain is what? All real numbers, negative infinity to infinity. So vertical asymptotes and holes come from domain restrictions. So if there aren't any domain restrictions, there are no vertical asymptotes and there are no holes. Now, folks, this page is technically in the non-calculator portion, but since we haven't gotten to that last part of Unit 5 yet, we don't know the shortcut for finding horizontal asymptotes without our calculator, so we're going to have to do it the old-fashioned way like we did on page 3, which makes use of our calculator. So first, make sure you trap the numerator and denominator in parentheses when you go to type it in. So there's my graph. Does it look like it has a horizontal asymptote that it's leveling off at? Remember, horizontal asymptotes aren't necessarily restrictions. They can be, but it's more about the end behavior of the graph. So method number 1 is using the trace button, so engaging trace, and just saying, let's just see where it looks like this is leveling off. If I were you, I'd be going, this is annoying, but perhaps 7 is what my Y value is approaching. But this is why the table ask is a little bit better. I'm going to go through the steps briefly, but you will find them on page 3 in the notes. Second window takes you to your table settings. You will want just the independent to be set to ask. And then you get to type in your own values, and what we want to do to figure out roughly what the end behavior or horizontal asymptote is doing is plugging in very, very large negative values and very, very large positive values to figure out about where we are leveling off. Where does it look like we have a horizontal asymptote? 7. And remember, your calculator lies. Well, it doesn't really lie. It rounds. So it's saying that we get to 7 even though we probably don't. So since 7 looks like what we are approaching, we would say that we have a horizontal asymptote at, what variable do I use to describe a horizontal asymptote equation? Y. So Y equals 7. Y equals 7. So I would put a little box around that because on the Unit 4 test, I did have a lot of people who just wrote the value and not the equation of the asymptotes. And that goes for the vertical ones as well. Any questions on problem A? Last problem, problem B. This problem, remember, we crossed off and replaced with something better. So let's start with talking restrictions. Are we going to have any? Yeah, we're dividing. There's variables in the denominator. So can we factor this one? Yes. GCF. So x, whoop, let's try that again. X times x plus 3. So what are my 2 restrictions of what x can't be?
X 0, -3.
Perfect. X can't be 0. X can't be -3. So what's my domain? All real numbers except for those 2 restrictions. So domain starts at negative infinity. Where's our first break? Careful. -3. We got to go in numeric order. -3. Parentheses. parentheses because that is not an included value. I can plug in everything leading up to -3, but as soon as I plug in -3, we're dividing by 0, and that's our problem. Union notation, -3 to 0, union 0 to infinity. So again, I've got both directions with the infinities because I don't have a square root restriction cutting it off. So there's my domain. Now we are going to classify these restrictions as either vertical asymptotes or holes. Does anyone remember the difference between the two?
Cancel out from the top and bottom.
Yes, it's all about what cancels restriction factoring wise. So I would write this off to the side. If the restriction factor cancels, it's a hole. If the restriction factor doesn't cancel, it's a vertical asymptote. Memorize that. So let's start with the restricted value of -3. Does the restriction factor x plus 3 cancel? Nope, there's nothing to cross off with it on the top. So that means we will have a vertical asymptote at x equals -3. So horizontal asymptotes are y equals, vertical asymptotes are x equals equations. So this one can't cancel. Now what about the x? If you're unsure, you can do 2 times x. 2x is technically in factored form, just 2 times x. So can I cross off that factor with that factor? Sure. So sometimes students get tripped up on the fact that there's a 2 in front of it. Since those are factored, you can cancel out just the x's with each other. So because we can cancel that restriction, we will have a hole at x equals 0. We're not going to find the y value here, just the x value. But if it helps you, remember that being able to cancel out that restriction, quote unquote cancel, is how we were able to find the corresponding y value of that hole. Because I can sort of cancel out that restriction, then I can sort of fudge things by plugging in that x value and find the corresponding y value that goes with it. So that's why holes, the restriction factor cancels. Vertical asymptotes, I'm just stuck with a big open spot for that whole x value. So I want you to use your calculator and see if you can determine if this graph has a horizontal asymptote. Go. Folks, those scientific notation values, what can we round those to? 0. They are very, very, very little numbers. So we can assume, both from our table and from the graph, it appears we have a horizontal asymptote at y equals 0. So, folks, that's it from me in this packet. However, there is one MyMathLab problem that I wanted to go over with you. So go ahead and get out your computers. And the problem we're going to be looking at is number 2. Now, notice on the work page for number 2, I say to solve using your graphing calculator and round to the hundredths place. On my math lab, it says solve the system graphically. I've had a few people who have tried to solve it algebraically. It gets gross, and the reason it gets gross is because we get decimal answers that we have to round to the hundredths place. So if it says solve algebraically, use substitution or elimination. If it says solve graphically, that means use your calculator. So in order for me to use my calculator on this, the graphing part of the calculator, we have to write both of these as equations in the y equals format. So here's equation 1. So I'm going to show this down here. Equation 1, I've got x squared plus y squared equals 25. If I want to get this as a y equals equation, I would subtract the x squared and then square root. So that y equals plus or minus. Can I simplify under that square root? No, Mrs. Caro, we're not going to do that because you cannot distribute a square root across subtraction like that. So that gross thing, even though 25 is perfect square, x squared is perfect square, we have to leave it like this. Now, sometimes students get to this point and they go, but hold up, there's not a plus or minus button on your calculator. You are correct. In order for us to graph this equation, which going back to what we did yesterday, what conic section is that? It's a circle. Coefficients are the same, with the same sign. So we know that's going to be a circle, which means choices A and C are out for the graph. So it's tricky because in order to type this equation in on my calculator, I have to write it as 2 separate equations. So in the y1 slot, I'm going to have the positive version of this equation. And again, your numbers might be slightly different than this, but the general process will be the same. 25 minus x squared, and then the negative version, negative 25 minus x squared. So 2 slots for that one equation. So I'm going to go to my y equals and type both of those in. So 25 minus x squared, and then negative square root of 25 minus x squared. So when I graph both of those, there's the top part of my circle, there's the bottom part of my circle. If you don't include the plus or minus, you're going to lose half of your graph and one of the intersection points. But that's not our system, that's just the first equation. The second equation is this one. So x plus y equals 4. To change this into a y equals equation, we're going to subtract the x. So 4 minus x, or negative x plus 4. So I'm going to put that one as y3. So 4 minus x. And there's our line. So we can clearly see that this should be choice D for the graph, but now it wants us to write the solutions to the system, typing an ordered pair and rounding to the nearest hundredth. Folks, pay attention to your rounding rules. That is important. And this one's a little bit different than the one we demonstrated yesterday, because yesterday we only dealt with the third prompt of using the guess, where it's like, yeah, move closer to whichever of the 2 points you're trying to find. This one's a bit more complicated because I have to be careful with those other 2 prompts of first curve, second curve. Folks, if you want to borrow one of my calculators during the test on finals day, you are free to do so, because on the older calculators that aren't colorized, it is a little bit tougher to tell which curve you are on. So I'm going to do second trace, intersect, and I can clearly see I am on the first curve, or the blue line. I'm going to press enter and select that blue line, and I'm going to decide to find that intersection point. It's asking me if I want the red curve as the second one. Do I want that one? No. So how you jump curves is using the up and down buttons. So I'm going to press up. Oh, that takes me to blue. I press up again, and now I'm on the black line. I'm going to press enter to select that as my second curve. I'm going to go up near that intersection point and press enter. And I can see that my intersection points would be rounded to the hundredths place. What's the x value? Negative 0.92. I remember on the test, some people miss the negative value, so just make sure you're reading stuff from your calculator carefully. And then for the y value, 4.92. The 5 bumps that digit up to be a 2, 4.92. Now, that is only one of the solutions. I'm going to put a comma there and find my other solution, following the same key sequence, second trace, intersect. Now, when it's sitting right there, especially if you're on the older calculators, it's like, what curve is it on? I can arrow over to the right to move it, and now if I was using an older calculator, I could clearly see that it's on the top curve. But we don't want to select that as the first curve, because my second intersection point is the intersection of the black one and the red one. So I'm going to press up to jump curves and select the black line. Enter. For the second curve, I don't want the blue line, I want the red line. So we're going to press up a couple times to jump to the red curve. Press enter. And now we're going to move closer to that intersection point. Whoops, moved too far. And that gives me the second intersection point, 4.92 and negative 0.92. And those would be my two solutions. So solving algebraically, not going to work very well for this problem. The calculator steps are important because you have to get the y equals equations first and break that plus or minus up into two separate equations.